we're now going to look at gaseous exchange in amphibians. That is the process that lead to, and actually the very process of changing gases between the atmosphere and the body of an amphibian. For example, a frog, a toad, a salamander, those are amphibians. Now, amphibians are quite unique because they have three ways of carrying out gaseous exchange. But let us first take notice of their young ones, which we refer to as the tadpoles. Tadpoles are very common in ponds because that's where mostly the frogs lay their eggs when the water is still or it is smoothly flowing. So tadpoles actually have tails and they breathe through gills. So they have gills, just like fish do. Now, tadpoles at first use external gills. Their gills are on the outside. They are extensions here, and they are not hard to see. But later on, the gills are covered, okay? So they become internal gills, and that's what they use as the surface for gaseous exchange. Now, tadpoles, remember, carry out, undergo their complete development in water. That's why amphibians are called so. Amphi for double, buoyant for life, because they start growing from water. So, within water, they use the oxygen that's dissolved within water and they obtain it through the gills. Now, oxygen diffuses from water to the gills and from the gills to the rest of the body, whereas the carbon dioxide from the rest of the body comes to the gills from where it diffuses into the water. And that's all about tadpoles. However, adult amphibians don't really use gills because they do not possess them. Instead, their gaseous exchange takes place through the skin, and let us start talking with the skin. The skin is very small. It's thin and wet. It's thin and wet. Now, the wetness on the skin attracts oxygen from the atmosphere to dissolve in that liquid on the skin, so that it diffuses. Right underneath the skin, there is a rich network of blood capillaries. Right under the skin, if you ever get a chance to cut a frog or a toad, we will flip to see that the blood vessels are very numerous on the underside. Now, the carbon dioxide from the blood capillaries on the underside also goes to the outside of the skin, where it escapes to the atmosphere. Most of the times they use the skin to breathe in water because the oxygen is there, things are much easier. However, they use mostly their lungs when they are on land or when the environment has become much drier. So that's simply how, gaseous exchange takes place across the skin. Unfortunately, you cannot have your gaseous exchange across the skin because your skin is firmly attached to your flesh. Unlike them, the skin is loosely attached to their flesh. And they're so lucky. I think they are. Now, the buccal cavity. Now, the buccal cavity means the mouth cavity, and the real gaseous exchange takes place in the lining. And how does this take place? The mouth cavity has a very thin lining, or what referred to as the epithelium, and it is at all times kept moist. Of course, yours is also kept moist, but it's not as thin, therefore you cannot use it for gaseous exchange. And it also has a very rich supply of blood capillaries that bring up the carbon dioxide from the body for exhalation and take away the oxygen to the rest of the body. for gaseous exchange to take place in the mouth, inhalation takes place. Now, inhalation refers to that process by which air enters, and during inhalation, first and foremost, the mouth closes and the flow of the mouth cavity, the flow of the buccal cavity lowers, something of this sort. Mouth closes and the flow lowers down. Now, when that lowers, there is an increased space within the mouth cavity. So the volume increases and therefore the pressure drops. Now, because of that, air rushes in through the nostrils to the buccal cavity or the mouth cavity. Now, gaseous exchangeability starts to take place where the carbon dioxide goes out of the blood and oxygen enters the blood, and it's carried away by the blood vessels, by the capillaries. Now, after gaseous exchange has taken place, the flow exhalation now takes place where the flow of the mouth cavity is raised. When it's raised, the internal volume of the cavity reduces. When the internal volume of the cavity reduces, the pressure inside the cavity increases, which forces the air out through the nostrils, and that is all. And therefore, a gaseous exchange in the mouth cavity is complete. But that goes on and on and on and on. So this is the summary. That's a summary. The flow of the buccal cavity lowers, internal volume of the mouth cavity increases. Now, actually this is the very same thing that happens to you when you're drinking through a straw. If you can do that right now, that will help us very much so that you understand the concept right now. Now, what happens is that you have a straw, you close your mouth firmly. Remember, you cannot suck through your straw when there's a space through which air can pass. So, when you put your straw in the mouth, you close the mouth. The flow of your mouth lowers, and your tongue actually also lowers. Now, when that lowers, the volume in your mouth increases. The cavity simply means that space, okay? So, the space, the volume of your mouth space increases and the pressure drops, and because of that the liquid you're taking rushes through the straw to the mouth. Now, what happens when you want to swallow or to spit out? You raise the flow of your mouth. Earlier on it was down, now you raise it so that your tongue almost hits the upper floor. Now that decreases the volume within the cavity and increases the pressure, which forces the fluid or whatever it is to go on, okay, down the esophagus. We're now going to look at the third and last part organ within the amphibians where gaseous exchange takes place, and those are the lungs. Now, inside the lungs, The particular part are the alveoli, where the real gaseous exchange takes place. That's to say, oxygen from air entering blood and carbon dioxide from blood exiting so that it can be expelled afterward. Now, the lungs consist of sacs, and sacs which we are referring to as alveoli, and have a very good network of blood capillaries. And these air sacs are actually very numerous. Alveoli are very thin-walled, and we're now going to see how ventilation takes place. Remember, ventilation refers to bringing in air and expelling that air after gaseous exchange. Now, during inspiration, the mouth closes, the nostrils open. The flow of the mouth lowers. That happens by contraction of the muscles in the floor of the mouth, so that the volume in the mouth increases. The increased volume leads to a reduction in the pressure within the mouth. Okay? Now, that causes air to rush through the nostrils to the mouth. Now, once air has reached the mouth, that's not the destination. It has to continue all the way to the lungs. Now, the nostrils close. A valve closes the nostrils, and so that air cannot go out now. Okay? Now, the volume of the lungs increases, and this is due to the contraction of the muscles. Okay? So, the volume of the lungs increases so that there is reduced pressure within the lungs. The flow of the mouth increases so that the volume of the mouth decreases and the pressure increases. Now, see, there's increased pressure in the mouth and decreased pressure in the lungs. That causes air to leave the mouth to go down through the glottis to the lungs. Okay. Now, when the air reaches the lungs, gaseous exchange takes place across the alveoli, so that oxygen from the air goes to the blood, and carbon dioxide from the blood enters this air that's within the lung space. Now, once gaseous exchange is done, the flow of the mouth now lowers. Volume increases, pressure decreases. The volume of the lungs decreases, pressure increases, and that causes the air to flow out through the glottis to the mouth, where there is lower pressure. Now, once the air has reached the mouth, the nostrils open. Okay, when the nostrils open, the mouth again rises, decreasing the volume and increasing the pressure. But the valve going down to the lungs closes the glottis so that air cannot go back. Now, after that, the nostrils have opened, the pressure has increased. That just causes the natural movement where air is expelled from the mouth through the nostrils to the atmosphere, and that happens on and on and on. Important for us to notice is that actually within amphibians, this kind of breathing is forceful. You know, air is forced in, forced down, forced out. You know, and that goes on all along. For as long as they are breathing, they are carrying out gaseous exchange with their lungs. Remember, we have movement from the atmosphere. Remember, when breathing in, the nostrils are open, air goes through. Okay. When air is going down to the lungs, the nostrils close. And when air is leaving the lungs to go to the mouth, the nostrils are closed. But when it's time for it to go out to the atmosphere, the nostrils open and the valve to the lungs closes. That prevents a confusion that would have been when both the entrance to the lungs and the exit through the nostrils are open. And so that is gaseous exchange in the lungs in amphibians.